I want to look at 3 more problems where we find the complex zeros and factor polynomials. So here's the first problem. It's find the complex zeros of f of x is equal to 3x to the fourth plus 5x cubed plus 25x squared plus 45x minus 18, and let's factor it completely. So when we're given a polynomial like this, first off, we look at the degree. The degree is 4, which tells me I can have 4 complex zeros. Now, they may not all be distinct, but I will be able to factor this and get 4 different zeros. Okay, next thing is I'm going to find my potential candidates. I'm going to start with rational zeros. So my potential rational zeros, remember how we find these. What we do is we take the number here, 18, find all the factors, and divide it by all the factors of 3. So we're going to have plus or minus. Factors of 18 are 1, 2, 3, 6, 9, and 18. All of these numbers factor 18. And on the bottom, all the numbers that factor 3 are 1 and 3. So to list them all, we're going to have a lot of them. We're going to take each one of these numbers and divide by 1, and then each one of these numbers and divide by 3. So we get plus or minus 1, plus or minus 2, 3, 6, 9, 18. And then we divide by 3, so we get plus or minus 1/3, plus or minus 2/3. And then if you divide these numbers by 3, you're just going to get some that we've already listed. So these are all the potential zeros. So there's 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 potential rational zeros. So what do we do from there? We choose some of them, and we start plugging them into the function and seeing if we get a remainder of 0. If we get a remainder of 0, then it is a 0. These are zeros or roots of our function, which means x minus that number will be a factor. Let's start with the number 1. Let's just plug it into the function. F of 1, so I'm going to plug it into here and see what I get. I'll get 3 plus 5 plus 25 plus 45 minus 18. Try to simplify this. Notice that the only negative number is 18 here. And all of these numbers add up to something greater than 18. So this is greater than 0. So 1 is not a, let me just cross out the positive part. 1 is not a 0 of this function. Okay, then you could try -1. I think what I'm going to try next is -2. So if you plug in -2 into this function, now this will be a little difficult, but I'm going to write it out. Let me zoom out a little bit, a little bit more. Okay, just plug this in, and I'm not going to do the math. You can do the math on your own. But this is just algebra, so what you're going to end up with is 0. So make sure that you get 0, and because when you plug in -2, you get 0, that tells us that -2 is a root of f of x, and x plus 2 is a factor of f of x. So what do we do from there? Where do we go? Let me zoom in a little bit. What we need to do is we need to take this long polynomial and divide it by x plus 2. So let's do that. I'm going to make some room here so I can see the polynomial. Okay, so I'm going to put x plus 2, and then I'm going to put this long polynomial under this division sign, 3x to the fourth plus 5x cubed 25x squared plus 45x minus 18. Okay. So we ask ourselves, what do we need to multiply x by to get 3x to the fourth? So that's 3x cubed. So multiply that. Then we get plus 6x cubed. Subtract. So we've done all of this before, so I'm going through it pretty fast. Pull the 25x squared down, and then minus x squared to get this x cubed. This becomes negative 2x squared. So subtract this, which means change all the signs, and we get 27x squared. Pull the 45x down. Okay, and we multiply by 27x to get 27x squared. This should be, so 27 times 2 is 54. So plus 54x. So we're going to subtract. And then this should be 45 minus 54 should be a negative 9x minus 18. And then we're going to have to multiply by negative 9. We'll get negative 9x minus 18. And then if you subtract this, you get 0, which is the remainder, which we had found earlier if you had plugged in all that stuff. So now we know that this factors into, let me put it over here. This is x plus 2 times 3x cubed minus x squared plus 27x minus 9. The next step is to try to factor this one. Now, we're going to need to find the potential factors for this new polynomial, which are actually going to be factors of the old one, but I'm going to focus on this guy here. Okay. All right, so to factor this, the potential zeros are plus or minus. We take this number here, negative 9, find its factors. They're 1, 3, and 9. Then we take this number, 3, and find its factors, 1 and 3. So the potential zeros that are rational are, let's write them over here, plus or minus 1, plus or minus 3, plus or minus 9. By taking these and dividing by 1. Also plus or minus 1/3. And then we get the rest we already have listed. So these are all the potential zeros. And let's see if any of them, if we plug them into the function, we get 0. I'm going to go ahead and tell you which one works. It's 1/3. So what you should do is you should take this function, call it g of x. And if you plug in, let me come over here and maybe zoom out a little bit. If you plug in 1/3 into this function, what you should get is 0. That tells us that 1/3 is a root. And x minus 1/3 is a factor. So I'm going to take this function and I'm going to divide it by x minus 1/3. So what I'm going to do is make some space. I'm going to do exactly what we did before. I'm going to copy this. Let's lasso, move it over here, and let's factor. How we factor is we take this, we put a division sign, and then we put what we're dividing by, which is x minus 1/3 over here. Okay, so what we'll get is, how do we get 3x cubed? Well, we multiply by 3x squared, and then send that into here. We'll get a minus x squared. So if you subtract this, you get 0. Pull these two pieces down. So 27x minus 9, we ignore that 0. To get that, we're going to multiply by 27. You'll get 27x, and 27 divided by 3, that's 9. We've got this negative, so if you subtract, you get 0, which is the remainder we expected. And now we're left with this 3x squared plus 27. So when we multiply x minus 1/3 by this, we get this piece here. So let's go back up here. I'm going to erase this. it's just a lot of stuff going on. And now let's start writing what f of x factors into. So we have 3x to the 4th plus 5x cubed, 25x squared, 45x, minus 18. We said that factored into x plus 2 times 3x cubed minus x squared plus 27x minus 9. Then we bring this x plus 2 down. We just saw that this factors into x minus 1/3 times 3x squared plus 27. Before we go any further, we're trying to get these into linear factors. Notice that we have a greatest common factor here. Try to zoom that a little bit. We can pull out a 3, so let's do that. This is equal to, put the 3 in the front, and then we get x squared plus 9. Okay, this x squared plus 9, this is prime over the real numbers, but because we're working over the complex numbers, we can find the roots of this. Now there's several ways to do this. Remember, for quadratic, you can use the quadratic formula to simplify this. But this is actually pretty easy to figure out, because if we set this equal to 0 and move the 9 to the other side and take the square root, we get the positive negative square root of negative 9, which is plus or minus 3i, because the square root of 9 is 3, and then we have the negative 1, which gives us the I. So now we're just about done. All we need to do now is break this up, and this is equal to 3x plus 2, x minus 1/3, and here are the other two roots. So x minus 3i and x plus 3i. Remember, if you have one imaginary number, you get its complex conjugate as well. So that is this polynomial completely factored into its linear factors. Great. So when you're going to see complex roots, what's going to happen is you're probably going to get a quadratic. It might be more complicated than this quadratic. And when you have a quadratic, we already know how to factor that. We use a quadratic formula. And that's what we did. Well, we didn't do that here, but you could have done it. So this is a different option we used. Okay, let's move on. I had a couple more problems I wanted to look at. Here I want to factor x cubed plus 6x squared plus 6x plus 5. I'm giving you a hint. This has one real 0 and two imaginary zeros. Because it has one real 0, and this real 0, to keep it easy, is going to be a rational 0. So let's see if we can find the rational 0. So let's write the candidates, the rational candidates. They are factors of 5 divided by factors of 1. So plus or minus 1 comma 5 over 1. Oh, so that's not too bad. We just have plus or minus 1 and plus or minus 5. So we need to plug in some of these numbers. One of them should work. And I'm going to go ahead and tell you which one it is. It is negative 5. So if you plug into your function, if you let f of x be x cubed plus 6x squared plus 6x plus 5, if you plug in negative 5, you should get 0. I'm skipping that step. You can double check it. And then you can check the other ones if you want to, but because this one works and we only have one real one, then all the other ones won't work because the other roots are going to be imaginary. Okay, so let's factor this. Let's take x cubed plus 6x squared plus 6x plus 5, and we're going to divide it by x plus 5. Remember, we always go with the opposite number here. So let me put over here, negative 5 is a root, which tells me x plus 5 is a factor. So we're dividing by x plus 5. Let's see what we get. This is x squared, we get x cubed, and then a 5x squared. Subtract. So this will be x squared plus 6x. You need to multiply this x by x to get x squared. So x squared plus 5x. Subtract. And look what we get. We get x plus 5, which is right here. So we just need to add 1 here, and we get x plus 5. And if we subtract this, we get 0. So we see that this function breaks into x plus 5 times x squared plus x plus 1. Let's write that here. So this is equal to x plus 5 times x squared plus x plus 1. Okay, we know that this is the only real root. That was the hint we were given. We have one real root and 2 imaginary roots. The 2 imaginary roots come from this quadratic. So we're going to factor this by using the quadratic formula. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. A is 1, b is 1, and c is 1. We can see that from this polynomial. So let's plug all of that information into the quadratic formula. So we get x is equal to negative b is negative 1 plus or minus square root. B squared is 1 squared minus 4. All of the coefficients here are 1. All divided by 2 times 1. Let's clean this up. This is negative 1 plus or minus 1 squared minus 4. So this is the square root of negative 3 divided by 2. And now let's write this using the imaginary number I. So we get negative 1 plus or minus square root 3i, because this is square root 3 times square root of negative 1, which is this, it's the I. So we keep the I outside of this square root, divided by 2. So we have these 2 imaginary roots. The roots are negative 1 plus square root 3i over 2, and also negative 1 minus square root 3i over 2. And so the factors are x minus both of these roots. So let me put that here. The factors are x minus negative 1 plus square root 3i over 2 and x minus negative 1 minus square root 3i over 2. Okay, so those look complicated. Now we're going to go back and let's finish factoring this. Okay, so let me put some space here. So let's recall what we did. We factored this polynomial here. Let me circle this and put it in white as well. We factored it into this piece, and now we've factored this as well. So now we get, this is equal to x plus 5 times, let's go to these factors and copy them. So let me just go like this, copy. And I'm going to put them here, and I'm going to fix them up a little bit so we get them in this nice factored form. So erase this, put some parentheses around this one. So it's x plus 5 times this one, and put parentheses around this guy. Make that one white and make it a little bit smaller. So what I did was I took those 2 factors I put them in parentheses, and now if we multiply all of this out, it's amazing what happens. These i's go away. So if you multiply these two together, you get this polynomial. And then if you multiply these two polynomials together, you get the original polynomial. And you can see we have 3 factors. Here, all of the factors are different. We have 3 factors, and they go with this number 3 here.